Hello everyone. So we're going to be doing the following problem. It states nitrate toxicity is due primarily to its conversion in the body to nitrite, NO2-, which interferes with the ability of hemoglobin to transport oxygen. Determine the formal charges on each atom in the nitrate ion. Okay, and they give us the chemical formula of NO3-. So if we're going to do formal charges, the first thing that we have to do is also draw the Lewis structure. So the very first thing that we do is we determine the number of valence electrons. So we know nitrogen donates 5 valence electrons. Oxygen, we have 3 of them. Each oxygen donates 6 electrons, and then we have the negative charge associated to it, so we have to include that as well, so 1 electron. Well, we add this all up, and this should give us 24 electrons. Well, now that we know that we have 24 electrons to distribute, we can then go ahead and draw the Lewis structure. So we know our central atom is nitrogen, the unique atom, and also the least electronegative. And then we place around the oxygens around the nitrogen. Oops. Once we've done that, we can then place our the remaining electrons and distribute them across the outermost atoms, and then corresponding to the nitrogen at the end. So we have 24 electrons to distribute. We divide that by 2, so we have 12 electron pairs to distribute amongst. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, once we've distributed the 12 electrons, we then make sure everything has its octet. So 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. We are good on that in that case. However, the nitrogen has 2, 4, 6. So we go ahead and we convert one of these lone pairs into a double bond. Make sure we also put the brackets. Okay, we convert this into its Lewis structure. Okay, perfect. Now that we've drawn its Lewis structure, we can then continue on with the problem. It's asking us to determine the formal charges on each atom in the nitrate ion. Well, when we do formal charges, remember we have the following equation. We have valence electrons minus the number, in brackets, the number of lone pairs plus bonding electrons divided by 2. So let's go ahead and do this for each atom. And what I like to do when I do this, if we have multiple atoms that are the same, I'll put like maybe an asterisk or some type of small symbol in order to identify it as I go throughout. So let's go ahead and start off with the nitrogen. So nitrogen is going to have 5 valence electrons minus the number of lone pairs. Well, we have no lone pairs. Plus the number of bonding electrons divided by 2, so 2. So we have 2, 4, 6, 8. 8 divided by 2 is 4. So we're going to have 5 minus 4, and so we're going to have a +1 charge on nitrogen. Let's go ahead and do an oxygen. I'm going to do an oxygen star, and I'm going to go from right to left. So this is my star. This is the very first oxygen I'm doing. So this one right here. Oxygen has 6 valence electrons minus the number of lone pairs, so 2, 4, 6. 6 lone pairs plus the number of bonding electrons divided by 2. So we have 2 divided by 2 is 1. And so we're going to get a -1. So 6 minus 7 is -1. These 2 oxygens are going to have the same formal charge. So each of these oxygens both have -1. The last oxygen that we have, okay, I'm going to do a plus sign, so I'm referring to this one right here. It also has 6 electrons, minus how many lone pairs? We have 2, 4. We have 4 lone pairs, plus how many bonding electrons divided by 2? So 2, 4 divided by 2 is 2. So we have 4 plus 2 is 6. 6 minus 6 is equal to 0. So we've identified the formal charges on each atom in the nitrate ion. Remember, it's important to note that both these oxygens, they have the They will have the same formal charges associated to them, and we've also determined the nitrogen and the unique oxygen. Remember, this structure is a resonance structure. If we haven't talked about that yet, we will, so just keep that in mind. Thank you.